Okay, this video is dedicated to two things. One is factoring out a GCF, and then more importantly, identifying a Pythagorean identity and then substituting that out with another trig function, and that way we can simplify it. So basically substituting with trig Pythagorean identities. So let's go ahead and take a look at the first example. Notice here that we see a cosine x in both the first and second term. So I'm going to factor out the cosine of x. And when you do that, you're basically dividing it out and putting it out front. So we have 1 minus sine squared of x. Okay. And what I say, now notice what we have here. We have cosines and we have sines. We want to convert this portion right here in parentheses to cosines. So what I'm going to do is I'm going to look over here at, here are the three Pythagorean identities. The first one is sine squared cosine squared equals 1. So what I'm going to do is, how can I make this function, or this statement, I should say, look like this up here, okay? Well, to do that, I need to move the sine squared over to the other side. So you simply subtract it, and we get cosine squared x is equal to 1 minus sine squared. All I did was move it over to the other side by subtraction, okay? And notice that the right-hand side and the left-hand side are equivalent. So basically what I'm going to do is substitute this with this here, okay? Because notice it's equivalent. So I'm going to rewrite it as cosine x, and then in place I'm going to write cosine squared. Now the nice thing about this is it takes it down from two terms down to one term. We now have like variables here, or like functions. So now we say cosine x times cosine squared of x is simply cosine cubed of x. Okay, basically three cosine functions in a row there. Okay, so that's a simplified form there. Okay, let's take a look. The same thing over here. I see that secant and secant are the same, so I'm going to take that out. Secant squared x. And we basically have tangent squared x plus 1. And notice that this is the same thing as that right there. So I look for which one of these has the tan squared function in it. That is equivalent to secant squared x. So I can just go ahead and substitute that away. You don't have to show all this work every single time, but you do want to get familiar with this, and you should be able to jump from this to this in one step. And now that we have secant squared x times secant squared x, we can simply say secant to the fourth x, okay? A nice simplified version of this expression.